and gentlemen, this is Ndefo Okigbo classes, lecture 2, where we discuss issues on engineering, science, and mathematics. My name is Ndefo Okigbo. I am a teacher of science, engineering, and mathematics. We started with lecture 1 the other day, and at that lecture 1 we were on forces. And that day we discussed forces in a straight line, the resultant of such forces, summation of forces in a straight line. Now today we're going to deal with forces that are at inclination, forces that didn't meet at a straight line. To talk about such forces, example of such forces is that two actions met at an inclination, at a point. Let's say two children were throwing ball at the ball meet the wall at the same time. The ball, and at an inclination, the wall has to respond in reaction. We want to get that reaction. That is the resultant of the effect of two balls. And then many other things that meet that way. Many other things that meet that way, we get there. So that's what we're going to talk about today. We're going to see how to calculate resultants of forces that are not in a straight line, forces that are met at an inclination. For instance, let's look at this. Let's look at this. Look at these two forces. Let's say there's a force here, force 1. Moving, and another force took over from here, force 2. You will see that these two forces, if you extend force 1, you will see that it met force 2 at an angle. For instance, let's say this angle is, let's even call it 90 degrees. If this angle is 90 degrees, that we have to calculate the resultant of the two forces. There are 2 ways we can, or 3 ways we can deal with this. We can, as force is a vector, we can deal with this using what the method called method of triangle, where we arrange these forces in a way that the third force, which is the resultant, we close the arrangement in the form of a triangle. We can also use the method of parallelogram, where if not that the angle is 90, if it is less than 90, we will use the method of parallelogram, where we can also close the forces and they form a parallelogram. Here, since the forces met at a right angle, we can also bring the forces together in form of a rectangle. Each of them will solve the problem to give us the resultant. Now let me look at it triangularly. Here, so let's take for instance that the angle, as we said, let's say it's 90 degrees. If you arrange these two forces, you will see that force F1 met force F2 at a right angle. The resultant, we close it. So if I want to solve this by method of triangle, what I will do is to draw any of them. If I draw F1 first, follow its own direction, I come exactly at the end of F1 and bring down F2, making sure that it is parallel. The one I'm drawing now is parallel to what the F2 that was given. That is parallel to the F2 that was given. So that means if it is parallel to F2 that was given, then the angle here will be 90 degrees. Then the resultant will move from F2 and end up back to F1. So the resultant, if the resultant does that, that implies that the triangle is formed. And it's simple. We can get that resultant using simple Pythagoras theorem, that r squared, which is the resultant, is equal to F1 squared plus F2 squared. We get R2. So for instance, supposing the angle between them is not 90. Let's say the angle between them is, for instance, let's say 120 degrees. The same way that this angle becomes 120 degrees. If I place R1, this is R1, the same direction and parallel to R1. I now bring in R2 at the end of R1, maintaining it at the way it is parallel to R2. R1, maintaining the way it is at the end of R1, R2 follows. If I care, I have R2. That's R1, R2. That's F2, sorry. I now close with the resultant. The angle here, since the angle here is 120, the angle here will be 180 minus 120. That is 60. The angle between them now will be 60 degrees. So the resultant, to get the resultant, in this case, because the triangle is no longer a right angle triangle, to get the resultant, simple. I use the cosine rule, whereby I have R squared is equal to F1 squared plus F2 squared minus 2 times F1, F2 cos that angle, in this case 60 degrees. With this, since I know F1 and F2, I can get the resultant R. That is method of triangle. Now, if let's say the angle between them, F1 and F2, the angle between them, this is F1, the angle between them is 30 degrees. They make that 30 degrees. F1, F2. The angle between is 30 degrees. Simple. I have F1. At the end of F1, I bring in F2. I bring in F2. So since this angle is 30, the angle here from 180 minus 30, that will give me 150 degrees. Now I now close to create the resultant. That's the resultant. Easy. To get the value of the resultant, the same cosine rule can do it. I have R squared is equal to F1 plus F2, F1 squared plus F2 squared minus 2 F1, F2 cos 150 degrees. Simple. I get, that is the method of solving forces that meet at an inclination by method of triangle. Now let's look at some examples. Let me try examples. Take for instance that R1 is equal to 3, R2 is equal to 5. F1 is equal to 3 newtons. Okay. Here, F1 is equal to 3 newtons. F2 is equal to 4 newtons. Let's see what is R by Pythagoras. Since this angle is 90 degrees, I have R squared is equal to 3 squared plus 4 squared. R squared is equal to 9 plus 16, which is 25. That means R is equal to the square root of 25, which is 5 Newton. You see, the reason why the Pythagoras theorem, the Pythagoras formula we have there, is also from the cosine rule. The only difference is that the cos of 90 degrees is 0. So if we are to bring it here, we will have, if we are to bring this here, we will have R is equal to 5. What is it? That is F1, that is 3. 3 squared plus 4 squared minus 2 times 3 times 4 cos 90. And the cos 90 is 0. That is 0 times 4 times 3 times 2. That is 0. It comes back to 3 squared plus 4 squared. That's why when they meet at 90 degrees. When you meet at 90 degrees, we just use the Pythagoras, in which we are not going to count for the angle, because the angle is 90 and the cos 90 is 0, and that removes this and bring it to this. Now, let us now change the values and see where the angle between them is 30. That if the angle between them is 30, when we arrange this is R1, F1, then F2, So the angle between them now is 150. We now produce the resultant. The resultant is R. Then in that case, if this is F1, so R is equal to, R squared is equal to 3 squared, which is F1, plus 4 squared, F2, minus 2 times 3 times 4. Cos, this time cos 150. So if we check for cos 150, so it becomes, this is 9 plus 12 plus 16 minus, this is 18 cos 150 degrees. So which is equal to 25 minus 18 cos 150 degrees. So immediately we get cos 150 degrees now, we just multiply by 18, subtract from 25, we get the square root, and we get R.